Hi, this is Jay with Jantech Services, and this is Good Stuff to Know. Today we're going to talk about battery life expectancy in your UPS system. We're going to assume that you're probably utilizing some form of lead-acid batteries in your UPS system. Here are some key drivers that will affect the life expectancy of those batteries. First and foremost is temperature. Lead-acid batteries want to live at 77 degrees Fahrenheit. If you run the batteries in cooler temperatures, you may reduce the capacity a little bit, but if you run them at higher temperatures, you generally will increase capacity slightly, but adversely, operating at 93 degrees Fahrenheit or higher will reduce the battery life by up to half or greater. So running those batteries at their optimum temperature of 77 degrees is key. Additionally, those batteries will emit some amount of heat during normal charging, so you do need good ventilation for those batteries. If you can allow a little bit of spacing between those batteries, that's even better. You have to apply a proper charging voltage. If you overcharge those batteries, they're going to tend to gas. If they gas, in the case of a valve-regulated lead-acid battery, they could potentially vent. If they vent, meaning there's a pressure relief valve in the top of those batteries, if that vent cap opens, you're going to introduce air into the battery, and that will ultimately accelerate the dry out of those batteries. Ripple current. You've got to have minimal ripple current in the charging applied to those batteries. If you have bad or old DC filter capacitors in your UPS, you're going to be sending dirty voltage to those batteries. The batteries are now going to act as a filter, but unfortunately that charging current, that high ripple content in the charging current, is going to bang on the battery plates like a hammer and ultimately destroy the batteries. So you have to have good, clean charging current and voltage to those batteries. Overcycling can be a problem. Not in the case of most valve-regulated batteries. They're going to produce anywhere from 1,000 to 2,000 discharges over the life of those batteries, so chances are you're not going to see that many discharges on your system. A natural occurrence inside of lead-acid batteries is grid corrosion. The plates are made from an alloy grid with lead oxide paste on them, and they're immersed in or submerged in a sulfuric acid. That acid is eventually going to eat away at the grid material. If the grid comes apart in pieces, the entire plate can fall apart. So grid corrosion is a big factor in standard lead calcium or lead antimony batteries. We'll talk about pure lead batteries at some later date, but for this discussion, we'll assume that you have lead calcium or lead antimony grids in the battery plates. Again, we already talked about dry out. If those batteries vent, you introduce air into them, you can dry the battery out, therefore having no more electrolyte in the battery, which is required. And then when we talked about temperature and ventilation, those batteries need to be able to emit and get rid of whatever heat they're generating. If you ever heard the term thermal runaway, the easiest definition of it is if the batteries start to heat up and they can't emit or reject and get rid of the heat that they're emitting fast enough, the temperature increase is going to cause the internal impedance or resistance of the batteries to decrease, therefore increasing charging current, heating the battery more, reducing, and you'll get into a runaway and dangerous situation with your batteries at that point. So these are key drivers that will affect the life expectancy of your batteries. And in the next video, I'm going to talk about how we can try to extend that battery life to the longest possible life we can get out of those batteries. See you on the next video.